Hey, what's up? Today you are watching ExpressiveSyntax. We're going to be doing more Ruby Koans. My name is Sam Backus. Let's jump right in. So, when we left off last time, we were learning about nil and objects. Today we're going to go right into the next one, which is about arrays, I think. So, I'm going to go and run my tests. About arrays. Sweet! Okay, so let's open that and get started. Dive right in. Okay, so about arrays, creating arrays. So you can do empty array equals array.new. So array.new works for making empty arrays. Empty array.class, empty array.size. So the class should be array, and the size should be 0 since it's empty. Let's see. Yeah, on to the next one. Line 18. Oh, interesting. Okay, so what are we doing here? Test array literals. So you can do make a new array, assert equal, the empty array is equal to the array. Yeah, that makes sense. And then array, set the 0th element to 1. So array is like a list, right? And we're putting the value 1 in the first kind of slot in that list of things. If that makes sense. And then assert equals, the first thing in the list is the array. Wait, what? Assert equal, yeah. So the array containing just 1 is equal to the array that we have. We can change the, we can add another element here in the second slot at position 1. So this will be 2. You can also add things to the array using this double arrow operator. So just stick something at the end. So right now our array should look like 1, 2, 3, 3, 3. So it has 3 values in our list. The first one is 1, the second one is 2, and the third one is 3. The reason is because we added 1 at the 0th position, 2 at the first position, and 3, 3, 3 at the next one. So let's see if that works. Rake on line 27. Yeah, okay. So I hope that makes sense. You can add things to the array by giving the place where you want to add it and then the value, or you can stick something on the end by using this arrow operator. Accessing array elements. So peanut, butter, and jelly is our array. So we have 4 symbols. First one is peanut, butter. The next one is and jelly. Okay. So, right. 0th element is peanut, which is also the first element. Peanut. The last element is jelly. Oh, and you can go from the end of the array. So the -1 element is jelly. We're kind of counting backwards. So like, yeah, from the end, -1, -2, -3 is butter. Oops, butter. Does that make sense? Let's see if that works. On to line 38. Yeah, okay, cool. So you can either, what do we learn here? You can either use the index by using these square brackets to access the values, or you can use methods like first and last. You can also count backwards, -1, -3, from the end of the list. Okay, so what's next? Slicing arrays. Okay. So this is, I remember that, I don't quite remember how this works, but I remember that it's different from how Python works. And I always get confused about that. So I think, does this mean, so slicing will give us a new array, and depending on what we put here, we'll determine what elements that new array has. So I think this might mean start at 0 and take one element. So our new array just has peanut. I don't slice elements. I mean, slice arrays very often. I think it might just be that. I'm going to check that one before moving on to the next one. On to line 39. Yeah, okay, so that's correct. And then I'm going to make this a little bit bigger so it's easier to see. How's that? That's good. And then, oops, make that a little bit bigger too. So our next array is 0 through 2. So peanut and butter. On to line 40, cool, so that's good. Okay, so here's where I get confused. Does this mean starting with element 2, take 2 and get and jelly? Or are we going from element 2 to element 2? Do you see what I mean? Let's try my first thought about that. So it's and jelly, because this is like the first number here is where you're starting, the second number is how many you take. That's my theory. Yeah, so on to 41. Okay, cool, got that right. Oh, interesting. So we can start at 2, which is and get jelly. But then there's way more. I mean, way fewer things in our array than 20. Does it give us an error, or does it give us and jelly? I think it gives us and jelly. Yeah, cool. So what does this mean? Start with the 4th element and take 0. What is our test saying? So this should give us the empty array? Huh. Because there is no 4th element, it's like the tail, right? And we're taking 0, so it's nothing. That kind of makes sense. And I'm guessing this also gives us an empty array. All right. So we're on to line 44. Yeah, okay. So we can take the 4th element. 4th element is sort of just the end, right? Nothing there. But what happens if we take the 5th element to equal nil? Interesting. Yeah. So the reason, like, you look at this and there's no 4th element, there's no 5th element. Why are these different? But there is kind of an invisible 4th element that we're not seeing. It's like the tail of the array, the empty array that everything else gets kind of tacked onto. And that kind of makes sense to me in a way. Knowing how arrays are constructed. Cool. So you can slice arrays, and the first number is like where you start, and then the next number is how many you take. That's the lesson there, I think. Arrays and ranges. Okay. So this 1.5 is a range. So I think we can type in range here. Assert not equal. Yeah, so an array is different from a range. They're just different types of things. That makes sense. But you can convert between them. So if you call 2a on the range 1 dot dot 5, it gives you 1, 2, 3, 4, 5, I think. Oh, no. Yeah. So 1, 2, 3, 4, 5. So what's the difference between 1 dot dot 5 and 1 dot 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 5? What's the difference between the 2 dots and the 3 dots? And the difference is that it's a not inclusive range. It doesn't give you, it's like 1 through 5 not including 5, and this is with 2 dots, it's 1 to 5 including 5. So let's try that. Yeah, cool. On line 57. Test slicing with ranges. So we've got an array, peanut butter and jelly, like before. Oh, and now we're, instead of slicing with this comma syntax, we're using more like a range syntax. So I think this is more like, so this is like starting at this number, take this many. This is like starting at this number and going to this number. So this will be peanut butter and, because remember the 2 dot range is inclusive, so this will include the and element. Yeah, but this is not inclusive, so I think what goes here is just peanut and butter. And oh, interesting. So we can we can kind of count backwards too here. So you can go from 2 to the end, and the end is indicated by the -1. So we're looking for and jelly, because and is the second and jelly is the last. So and jelly. Let's try that. Does that work? Is that happy? On line 66, yeah, doing good. Doing good. Crushing it. Pushing and popping arrays. So we have an array, 1, 2, and we can push, use this method push to add a thing. And push puts it onto the end, I believe. Kind of like those double arrow operator that we saw earlier. I think. Let's test it. So we've got 1, 2, and the symbol last. And I guess, yeah, it makes sense. They're kind of giving me the answer here with this this clue, giving me a clue by naming it last. So I'm feeling good about that. So we pop a value. Here we can do popped value equals array.pop. So this is a method that pops the last element off of the array. So popped value will be last, and it also removes it from the array, interestingly. So this will be 1 and 2. And where are we? Line 77, yeah, cool. Got all those right. Shifting arrays. So this is kind of like pop. Shifting is like popping, except it's from the beginning instead of from the end. So you can unshift the first element, and that puts something at the beginning of the array. So it's asking me what the array is going to be. So yeah, so it's first 1, 2. And then the shifted value is equal to array.shift, and it wants to know what the shifted value is. So the shifted value will be first, and the array, similar to pop, it removes it from the array. So let's try that. Yeah, cool. We're good. Nice. On to about array assignment. So I'm going to open that up. About array assignment. Test non-parallel assignment. So names equals the array John, comma, Smith. And we assert equal I mean, this seems pretty straightforward. I'm not sure what it's getting at here, but let's try John, comma, Smith. Yeah. So now, what are they trying to teach us here? Non-parallel assignment. I don't know. Maybe we'll find out more if we do more. So test parallel assignment. Oh, I see. This is non-parallel assignment because it's like assignment like we're used to. You have a variable and you make the you set the value of that variable to the array. But here, we have two variables equals the array, and this will kind of split the array and give first name the value of John and last name the value of Smith. Cool. That makes sense. So you can, if you're have a bunch of variables and you want to assign values to each of them and kind of do it in one line, you can use parallel assignment. This might be useful in other situations too. That's cool. Test parallel assignments with extra values. What happens to the extra values? I wonder. My guess is that we'll have John here, and then the array. I'm guessing that it uses the shift operator that we saw last time. So this might be Smith the third. That kind of makes sense. Let's see what it says. Oh, I was wrong. It just takes Smith and then forgets about the third. Okay. So is that right? On line 23, yeah, okay. So when we just have an equal sign here, it'll just take this one goes to this, and this one goes to this, and then we're done. But we can use parallel assignment with the splat operator, and this is what I was thinking of. So this will be John, and this will be, I'm guessing, Smith the third. Let's try it. 29. Yeah. Okay. Cool. So the splat operator says, I guess, like, give me the leftovers, give me everything. Parallel assignment with too few variables. Oh. Huh. What do you think this was going to do? Any guesses? Any ideas? Here's my idea. No, it's a silly idea. Nil? I bet it's nil. I don't know. We'll see. 35. Oh, I was right. It is nil. Cool. Test parallel assignment with subarray. First name, last name equal Willie Ray Johnson. All right, yeah. So this will be Willie Ray. And this will be Johnson. Right? 41. Test parallel assignment with one variable. How is this different than the first thing that we saw? Names equal John Smith. First name equals, oh, there's the comma, I see. So comma is the thing that does the makes parallel assignment happen. But we don't have a second thing, so it'll just be first name based on the context clues that they're giving us. 48, yeah, okay. Interesting. Swapping with parallel assignment. What is swapping? So first name equals Roy, last name equals Rob. First name, comma, last name equals last name, comma, first name. So, okay. So first name is Roy and last name is Rob. But here we assign last name to first name and first name to last name. So, oh, this is so confusing. So first name is going to be Rob and last name is going to be Roy. Hey, hey, hey. Cool, and we're on creating hashes. That went pretty quick. I'm gonna just check how long creating hashes is, and I might keep going. Let's see. Creating. Why is it finding it? Hashes. There we go. Oh, it's about hashes. And the name of the test is creating hashes. How long is this? Yeah, we'll do this real quick. Those will be fun. All right. So, creating hashes. Boop, 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 boop. So we can do hash.new. Like most objects, it has a new operator. Empty hash.class is obviously hash. Assert equal empty hash is this. Assert equal, what did I just do there? Yeah, okay. Empty hash.size is also 0. Does that work? Rake. Line 13, yeah, okay, doing good. Test hash literals. So here's the other way you can make hashes. Instead of calling hash.new, you can create a hash. And hash is a list sort of similar to an array, except instead of a numbered list, it's like a named list. Each element has a name. In Python, they're called dictionaries. And I think that kind of makes sense, right? There's a word associated with a definition. A word associated with a definition. So dictionary, it's kind of a nice analogy, I think. But you can use, it doesn't have to be a symbol here and a string here. It can be any kind of object here and any kind of object here. They'll probably get to some of that stuff, but having that analogy of a dictionary might help understand what a hash is. Test hash literals. So we're doing hash equals the hash of 1 to uno and 2 to dos. So hash.size is, what do you guess? You might think it's 4 because there's sort of 1, 2, 3, 4 things, but it's actually 2 because there's 2 sort of definitions. There's this, and there's this. There's 1, and then there's 2. So I think it's 2. Rake. On to line 18. Nice. Test accessing hashes. So we have the same hash, 1 to uno and 2 to dos, saved in the hash variable. And we do hash of 1 is string uno, and hash of 2 is the string dos. Muy bien. And the hash of doesn't exist is nil, because it does not exist. On to line 25, yeah. Easy peasy. Accessing hashes with fetch. So now we just have a hash with 1 goes to uno. And we can call this method hash.fetch on the element on the symbol 1. So that will give us uno. It's just like doing this, but a little bit more verbose, I guess. Assert raise fetch does not exist. Okay. Let's see what this gives us, because I'm actually not sure. So the answer, fill me in error expected, but key error, key not found. So this is the error that you get. Key error, key not found doesn't exist, was raised. Key error is the kind of error that you get when you try to fetch something that doesn't exist in your array. So I guess I lied a little bit, right? Because the fetch operator and this square brackets operator are not quite the same. Because when we do square brackets on an item in the array that doesn't exist, it gives us nil, and the fetch actually throws an error. So I guess depending on whether you want it to throw an error, if you try to get something that's not there, you might want to use fetch instead of the square operator. Cool, I'm learning stuff. That's pretty cool actually. Key error. So we want to put key error here to make the test pass. Think about it. Why might you want to use fetch instead of the square bracket operator when accessing hash keys? Yeah. What's an example? I can imagine a scenario where so maybe maybe I don't want back nil. Or actually maybe I want to store, maybe I want some of the values in my array to be nils even. It's kind of weird. But then I want to be able to tell the difference if I'm getting a nil back or if I'm getting an error. Oh, what is this? Go away. Might be one example. I'm trying to think of a good concrete example, but not coming to me right now. If you have any thoughts, good example of where you might want to use fetch instead of square brackets, post it in the chat, post it in the comments. Move on to the next one. Test changing hashes. So hash of 1 to uno and 2 to dos like we have before. And, oh, here we go. So we can use the square bracket operator to access the 1 element and the equal operator to reassign it. So we reassign it to 1. So now expected equals 1. 1 should be this. Assert equal expected. Yeah. Bonus question, why was expected broken out into a variable rather than used as a literal? I assumed it was for my convenience, so I didn't have to type this whole thing out again. But also because it makes it easier to read to split this up a little bit more, maybe? I don't know. It's a good question. I think that's probably the main reason for readability. You can say it's nicer to have that expected variable than it is to have this hang in here, which you could do, but like look how long and ugly that is. It's much nicer to be like, this is what's expected, and then we are saying we compare the expected to the hash. Yeah. Test his unordered. Hash is unordered. So we have a hash 1. It's equal to 1 to uno and 2 to dos. And then hash 2 has the same elements but in a different order. And we want to assert that they are equal. Yes. Have I run my test recently? Guess not. I'm on 55. Yeah, we're doing good. Test hash keys. Hash. Okay, so we can get a list of the keys by calling hash.keys, and the keys are the first elements, the sort of word part of the dictionary, right? So use the keys to find the definition. Hash keys. So when we do hash.keys.size, that gives us a list of the keys, an array of the keys, and the size is 2 because there are 2 keys, 1 and 2. And that is true because hash.keys does include 1 and hash.keys does include 2. And hash.keys.class is an array. So maybe it'd be useful to see that actually in action. So if I do have this hash, right, and I can call hash.keys, it gives me back this array. Capiche? Test hash values. So the values is similar to keys, except it returns the values. It'll return uno and dos in an array. So similarly, the size is 2. That is true. That is true. And the class is also array. So once again, I'll show that. So we have our hash, and we can call hash dot values, and see that it's an array, and it contains the 2 values. Cool, cool, cool. Combining hashes. Ooh, fascinating. So we have hash equals the string Jim goes to 53, Amy to 20, Dan to 23. So I guess this is like supposed to be a hash of ages, names and ages. So you can look up someone's age by their name. We have a new hash that is hash.merge, and the merge takes another hash, what has Jim to 54 and Jenny to 26. So hash is not equal to new hash, right? Of course not, because we added a bunch of elements to the new hash when we merged it with hash. And let's just fill in some of these. So expected equals new hash. So Jenny. Oh, interesting. So so I misspoke earlier when I said that it was adding. It is adding things to hash when it merges them, but notice here that there's 2 keys that are the same. Jim is in the original hash, and it's in the hash that we merge in as a key. So what will the value of Jim be when we're done merging? Will it be 53 as in the original hash, or will it be 54 as it was in the hash that we merged in? And I think when we merge, it prefers the values in the hash that you merge in over the values in the original hash. So the value of Jim will be 54. Notice there's yeah. So instead of having two things with keys called Jim, that doesn't really work. It replaces the old value with the new value. True. Let's try that. Oops. Break to run it. 83. Yeah. Okay. Cool. So what did we learn? We learned that hashes, when you merge, it can add elements, but it replaces values if the key already exists. Test default values. The next thing is testing default values. So hash1 equals hash.new. Hash1 is equal to 1. Assert equal hash1 of 1 is equal to 1. This is nil because we haven't added anything for 2 yet. Hash2 equals hash.new with passing in dos to the new constructor. Hash2 1 is 1. Oh, okay. So testing default values. So we pass in, when we create the hash, we pass in dos. This is the default value. So we set the value of 1, so that's 1. But for anything that would normally give us nil, now it gives us the default value of dos. I think that's correct. 99, yeah. Interesting. So you can give it a default value. Default value is the same object. So we hash.new with hash equals hash.new. And here we pass in an empty hash as the default value. We set the value of 1 to uno. Wait, what? No, it's not quite it. We append uno to the array at 1, and we append dos to the array at 2. So hash1 is equal to uno, and hash2 is equal to dos, and hash3 is equal to the empty hash, the empty array. Oh, this is very interesting. Let me try that. 99. So I got that wrong. Expected uno to equal uno dos. Okay, why? Why though? I see, I think. So the default value is this empty hash. Okay, so the thing that they're demonstrating here is that the default value is the same object. So the default value is this empty hash. And when we call hash1, there's no 1 key, so that we're adding to the default value, we're adding to this empty array, putting the value uno in there. We call hash2, there's no 2 key, so this is also using the default value, this empty array, and we add dose to that. So that's why when we call hash1, still no key called 1 in there. So we give back the default value, which is this array, uno dos, that we've been adding things to. Similarly, with 2, it's uno dos, I assume. And hash3 is weirdly also going to be uno dos. I guess it's not weird, like based on what we've learned. That makes perfect sense. Dos. Let's try that. So line 103. Okay, yeah. Wow. Okay, cool. Interesting. So the default value, we modify it. It's the same thing each time you do something to it. So this is actually useful because I've been in situations where I've used this, I think, to make like hash lookup things where I wanted to change the default value and add to it over time. I can't remember the specific the exact thing that I was doing, but this is actually kind of a useful feature to remember if you're doing stuff with hashes. Hash1. Okay, so what are we looking for here? Hash1.objectId equals hash2.objectId. Since these two methods, this both return the default hash, they're the same object, they should have the same ID. It is the same object, it should have the same ID. So that's true. Alright. Alright, last one. Here we go. Default value with block. Hash.new. Yeah. So this is what I was thinking of. This is what I've used before. The default value is a block that adds things that, yeah. Okay. So we make a hash using the new, and we give it a block. And the block takes two sort of parameters, the hash and the key, and when we so the default value is this block. So when we put something in a hash, when we call a oh man, running out of steam here. Okay, this last one. Get through this. When we call one of these accessor square block methods on the hash, this block executes, and the thing that's returned, the thing that happens is that we assign the empty array to that key. So here, let's walk through this. So here we have hash of 1. There's no hash of 1 yet. There's no thing called 1 in the array yet. So we use this default block to create that key and give it the value empty string. And then we return that and assign uno to it. Here, there's no value 2 yet, so the block gets executed, we assign We create the key 2 and assign the empty array to it, and then dose gets assigned to that. Whew, okay, right. So the hash of 1 is going to be uno, I think. The array of the string uno. And the hash of 2 is going to be this, the array of the string dos. And the hash of 3, what? Is going to be the empty array. Is that correct? Yeah, nice. That's super cool. So, right. So this is actually the thing that I was thinking of. This is what I used. This is a way of making sort of a self. What's the word that I'm looking for? A lookup hash. So say you have some function that takes a long time to run. The first time you give it a value, you can it has to run the algorithm, run the code, but then you can save it in a hash with the value that you passed in and the answer as the key is the value that passed in, and the value is the value that you calculated. But you want to kind of generate that as you go, and this, using the default value with a block, is one way to do that. You just add to the hash as you need to. With each time you calculate a new value, you add that to your hash. Yeah, useful stuff. All right. Whew. Oh man. Cool. Well, I hope you learned some stuff. What did we learn? We learned about hashes. We learned how to put things into hashes and get things out of hashes. We learned how to merge two hashes together. We learned that when you merge two hashes together, if there's conflicting keys, the new key, the one that you merge, is that value gets overwritten by the one that's getting merged in. Oh, you can look up things either using the square bracket syntax or using fetch. Was that with hashes or with? Yeah, and when you use fetch, if it doesn't exist, it throws an error instead of giving you nil. It's interesting. What else do we do? We learned about arrays. Oh, we can split arrays using the square bracket comma syntax. We can also split arrays using ranges. Yeah, cool stuff. Array assignment. Oh, we learned about parallel assignment and different ways of doing that. A little bit about the splat operator. You can use the splat operator to like get the rest of the things into that variable. Cool. Well, I hope this was educational. I gotta run. This has been an episode of ExpressiveSyntax. You can follow me online at on Twitter, ExpressiveSyntax on Twitter, or I'm on Twitch TV and YouTube. ExpressiveSyntax is what to Google. I'm gonna do this again. This is fun. Hopefully, I'll be a little bit more awake next time. Give it a little bit more energy. Thank you for watching. Mwah! Bye. Stop. Oh no.